All right, today we're going to start to simplify radicals. What we worked on yesterday, everything worked out nicely and we had all perfect squares or perfect cubes or perfect fourths. So today we're going to deal with what do you do if we don't have a perfect square, perfect cube, or whatever under the radical. So we're going to do that with numbers, and we're also going to do that with variables. So I've just got two examples up here at the top for you guys to look through. I'll kind of explain what's going on here. 72 is not a perfect square, and x cubed, remember if we have a square root, they don't write the 2 in there as the index, but that's implied. So what you want to notice though, what we were doing yesterday, we were just dividing the exponent by the root, everything was great. Now in this case, 3 is not divisible by 2. There's going to be leftover or a remainder if we would divide that. So what happens is we end up with variables possibly still under the radical. So I'm just going to walk you through the easiest way I can tell you to do this. First thing you want to do is factor 72. You want to try and find the biggest perfect square. And if you guys look down the page over here on this side, I have the perfect squares, perfect cubes, and perfect fourths on the paper for your reference. But 72 is not a perfect square. You want to find the biggest perfect square that divides into 72. So if you're looking at your list, and if you prefer a factor tree, you can do a factor tree, but I would always start out and test 4. If 4 goes in, I also know 9 goes in. Now, if I see 8, when I divide that by 9, I know that a bigger number is going to go in here because 8 is also divisible by 4, which is a perfect square. So I just start checking it out. 16 doesn't go in. 72, let me divide that by 36. Now 36 times 2 is 72. That's the biggest perfect square that's going to go in there. So just real quick, rewrite as 36 times 2. And then in terms of the variable, you want your exponent to be divisible by 2. So I'm just going to recommend breaking this apart. This still represents x to the third if I break that apart into x squared and x. What happens though is I can actually take the square root of this. Now to be honest with you, I probably wouldn't do these steps over here. What I would do is I'd say, okay, square root of 36 is 6. So that's going to come out in front. The 2 is going to stay under the square root because I can't simplify that. The square root of this x squared is x. That's going to come out in front. Can't do anything else here with this plain x, so stuck under the square root would still be the 2x. And I'll do my own process a little bit down here. This is just a breakdown of step by step everything you could possibly do on these problems. Now, next to this, this is I think going to be a little bit harder mindset because you guys are probably not used to breaking down higher powered roots. So this is a cube root. And I know you can't see them on the screen right now, so I'm going to just write them real quick. Your perfect cubes, 1, 8, 27, 64. You guys can see this list down the page. I'm going to do the same thing. Biggest cube root that'll divide into 80. Now, I know right away that's 8, but I would just divide it real quick to check, like 10, not divisible by any other number on the list besides 1. So make sure you're looking at perfect cubes when you start to break down a cube root. So rewrite 80 as 8 times 10. Now, similar concept to what we just looked at. I want to be able to divide the exponent by the root. 8 is not divisible by 3. So what you want to do is break that apart into an exponent that is divisible by 3. So 6 is divisible by 3, we'd have 2 left over. Now again, right from here, I would probably not do all the steps that you see below. What I would do is say, okay, cube root of 8 here, I can pull out a 2, that's a perfect cube. Cube root of n to the 6, if I divide 6 by 3, I can pull out an n squared. Now the 10 and the n squared, those can't be broken down further, so you have 2n squared out in front, and then still stuck under the cube root, you have that 10 and that n squared. And I just want to show you this real quick to the side if this helps anybody in any way. You can actually divide here if I think about a little long division. I'm going to divide 8 by 3. 3 goes into 8 twice. This would be 6, and your remainder would be 2. If you actually look at the answer, I was able to pull out n squared that would match up with that. The remainder of 2 is why I still have n squared left under the radical. So if that helps you in any way, like over here, if I do this, if I do 2 into 3, that goes 1 time. 1 times 2 is 2, 1. So you see right here, I have 1x that I was able to pull out, and my remainder of 1x underneath the square root. So if that makes sense in any way, you can definitely use that. Alright, so we're just going to go through and practice problems, and I'm going to break these down probably a little faster than you would because I'm familiar with the numbers. But if I'm doing a square root, I want to think about perfect squares. So here I have them over here. 18 is not a perfect square. I want the biggest number on this list that'll divide into 18. If you're not sure, just start dividing 18 by the numbers on this list. Biggest number that goes in here is 9. And you have to rewrite it as a product. 9 times 2. Now here's what you guys know. 9 is the perfect square. So I'm going to pull that out in front. The square root of 9 is 3. Can't do anything with the 2, so that has to stay under the square root. This has a number and variable. Now, we just broke down a 72 in that one up above, so I know that that's 36 times 2. Okay, now a to the third. 3 is not divisible by 2, so I'm going to break this apart into a squared times a. If you want to write the little 1 exponent to think about that. This still represents a to the third, but I'm just breaking it apart so I can take anything out. Now, b to the fourth. 4 is divisible by our square root, so I'm going to leave that alone. Okay, and just take anything out. So square root of 36 is 6. The 2 is going to have to stay under here. Square root of a squared, we can pull out an a. Square root of b to the fourth is going to be b squared. Okay, all this is going to come out in front. 6ab squared. 2 still stuck under here, a still stuck under here. Couldn't break those down any farther. Okay, now the last one, I know what it is, but I know you guys are probably not sure. So just take a process. So let me divide 108. I'm going to start out and I'm going to divide that by 4. Okay, 27 I know is also divisible by 9, so 9 is a perfect square. Let me check that out. Now I know 12 is also divisible by 4, so I'm not getting the biggest perfect square here. So if 9 and 4 go in, I would try 36, and that's what's going to be what's going on here. 108 is 36 times 3. Alright, now p to the fifth, not divisible by 2, so I'm going to do p to the fourth times p. Q squared, that's divisible by our root, so I'm going to leave that alone. Alright, so out in front, square root of 36 is 6. P to the fourth, divide the exponent by the root, we can pull out p squared. Q squared, divide the exponent by the root, this will be a plain q. So the front side of this is going to be 6p squared q. Now, still under the radical, we couldn't break down the 3 and the p to the first, so still under the square root, 3 and a p. Alright, now I'm going to switch over to cube roots. I put the cubes right next to this example so we can try this out. Remember, it has to be divisible by a number on this list, and we're not talking about adding, subtracting, we're talking about dividing. Okay, 48 is divisible by 8. You probably know this, but I'm just going to show you real quick. 48 is not divisible by 27, so 8 was our only bet here. So I'm going to rewrite this. This is the cube root of 8 times 6. Okay, now your cube roots here, this is 1, 2, 3 on down the line if you take the cube root of these. So cube root of 1, cube root of 8, cube root of 27. On down the line, it just goes 1, 2, 3, 4. So the cube root here is 2. 2 to the third power is equal to 8. So basically what I have going on here is the cube root of 2 to the third, where the cube root and the third power are going to cancel each other out. So this is a 2. Okay, now make sure you write a cube root, not a square root, because that's what we're dealing with here. Still under the cube root is 6. 6 is not divisible by any number on that list besides 1, and that's not going to help you break anything down. So this would be the simplified form. You can take the cube root of a negative number. Again, we're going to use 8 here. 27 is obviously not going to divide into 24. So this would be what I would say, negative 8 times 3. I'm going to break down my exponent here because 4 is not divisible by 3. So I'm going to write x to the third times x. Okay, now cube root of negative 8 is negative 2. Cube root of this x to the third exponent divided by the root is x. And we're going to have a couple terms trapped under there. So this would be negative 2x cube root of 3x. And then we're going to do one more here. 54. You guys might know this off the top of your head. So 54, I'm going to just check these out. Not divisible by 8. 54 divided by 27. That does work. So it's 27 times 2. So I'm just going to rewrite this real quick. Okay, a to the 7th. 7 is not divisible by 3. So I'm going to break this into a to the 6th times a. That's still a to the 7th, but we're breaking apart so we can remove any perfect cubes. 10 is not divisible by 3, so I'm going to do b to the 9th. The biggest number that you could think of in that exponent that 3 would divide into is what you're trying to do. And then b to the 1st. Okay, so cube root of 27 is 3, so I can pull that out in front. A to the 6th exponent divided by the root becomes a squared. B to the 9th exponent divided by the root, that's going to be b to the 3rd or b cubed. And we have several things left under here, the 2, the a, and the b. So here I've got 3a squared, b cubed, all that out in front. This is still a cube root, and what's left underneath is going to be 2b. And we're going to do one more set. I'm just going to do the front side of these notes if you're looking at them on the computer. So we're just going to do the front. Now, these are fourth roots. So here's your perfect fourth. So make sure if you're doing fourth roots, you're thinking about numbers on this list. All right, so I got 48 again, but we're doing a fourth root here. 48 is divisible by 16. Obviously, 48 is not divisible by 81. So 16 was our only bet here to even try. I can break this down. This is the fourth root, 16 times 3. Okay, now the way these work, same concept. The fourth root of 1 is 1. The fourth root of 16 is 2. The fourth root of 81 is 3, and then on down the line there. So what you have here is really, I'm going to pull a 2 out from this. 16 is 2 to the 4th power, so the 4th power and the 4th root are going to cancel each other out. That's why this pulls out as a 2. The 3 is still going to be stuck underneath here. So this is going to be 2 times the 4th root of 3 in simplest radical form. Okay, 162. And I just covered up the number, sorry. And that's a glare, so we're going to try to lay it right here. Okay, 162 divided by 16 doesn't go in. 162 divided by 81, and that actually goes in. So we can break this down. I'm going to rewrite this as 81 times 2. Now, don't be pulling out a 9. I know somebody's going to do that in their thought process. We're doing a fourth root here, though. Okay, for my variables, 5 is not divisible by 4. So let me break this into the biggest number that 4 will go into, and I'm going to do x to the 4th times x to the 1st. Remember, when you multiply like bases, you add the exponents to get the total back together. So this is x to the 5th. Now, y to the 8th here, we're in good shape because 8 is divisible by 4, so I don't have to break that up. Okay, so 81, this is 3. What you have going on there, you have the 4th root of 3 to the 4th. 3 to the 4th power is equal to 81. That's why I'm able to take out a 3. The 2 is going to have to stay where it's at. 4 exponent divided by root 4 would just be x to the 1st, or just an x. This x is extra. It's going to have to stay underneath. And then 8 exponent divided by the root 4 is going to be y squared out in front. So 3x y squared, 2 stuck, x stuck. Make sure you put it under a 4th root. Okay, and then I have one more. So let me slide this to the side here, guys. Let's see, 64 is divisible by 16 and then 4. 81 is going to be too much, and I know you cannot see that on the screen, but 64 is divisible by 16. So we're going to rewrite this. 16 times 4. Okay, 7 is not divisible by 4. This one, the biggest number 4 that's going to break down into the 7 is going to be x to the 4th, x to the 3rd. So we're going to have 3 x's left under here. Now, y to the 12th. 12 is divisible by 4, so I'm just going to leave that alone. Okay, the 4th root of 16 is 2. Don't be writing a 4 out here. The 4, we're doing a 4th root. 2 to the 4th power is 16. The 4th root and 4th power would cancel out. Exponent divided by the root, 4 divided by 4, this would just be x to the 1st. And exponent divided by the root, 12 divided by 4, this will be y to the 3rd. Now, still stuck underneath here, I got a 4 and an x cubed, so leave those under your 4th root. Out in front, 2xy cubed, 4th root, 4x cubed is your final answer there.